Okay, welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we are going to be looking at how to solve problems involving trig ratios. So by the end of this lesson you'll be able to find sine, cos and tan theta from a diagram, use Pythagoras' theorem to find an unknown side, and solve problems involving trig ratios of any angles, of angles of any magnitude in both degrees and radians. So let's have a look at the first part of this lesson, which is how to find sine, cos and tan theta from a diagram. In particular, in a circle with the four quadrants, where in the first quadrant all trig ratios are positive. In the first quadrant only sine. In the second quadrant only sine. In the third quadrant only tan, and in the fourth quadrant only cos. So here we're going to write down the values of sine theta, cos theta, and tan theta for each of the following. And the important thing to remember is that theta is always from east of the origin in an anti-clockwise direction until it hits the line that protrudes from the origin. So that's the angle we're talking about, until it hits that line. So here this is theta. So we want to find sine of theta. We know sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is equal to opposite over adjacent. So if we wanted to work out what the coordinates of this point is, the coordinates of that point is cos theta sine theta. 3/5, 4/5. Okay, and it's important to remember all stations to central. So here, all of these are positive. All of these trig ratios are positive. All right, let's have a look at question B. It's important, again, to remember that this angle is theta. Okay, so let's assume that this reference angle is alpha. So all stations to central, if we want to find sine theta is equal to sine of alpha in this case, because it's positive, only sine is positive, which is 8/17, opposite over hypotenuse. If we want cos of theta is equal to negative cos of alpha, because in this quadrant, again, only sine is positive. So it's negative cos alpha, which means cos alpha is 15/17. So it's negative 15/17. And tan of theta is also going to equal to negative tan of alpha. Tan is 8/15, so it's negative 8/15. Okay, so that means if I want to work out what the coordinates are of that point, the coordinates of that point here are cos theta, sine theta. That's the coordinates of that point. Alright, maybe pause the video, have a go with C and D yourselves, and when you're ready to check your answers, just continue playing the video. Okay, so it's important to remember that this here is theta. So this little bit here, that's alpha. Okay. All stations to central. So sine of theta here is going to equal to negative sine of the reference angle alpha. Sine of alpha is opposite 24/25. But because it's negative, we put a minus sign there. Cos of theta is equal to negative cos of alpha. Because remember, only tan is positive in this quadrant. Cos of alpha is equal to 7/25. So it's equal to negative 7/25. And tan of theta is the same as tan of alpha. We know it's positive, which is equal to 24 over 7. Okay, and it's positive. Alright, question D. We know that this is theta. That's alpha. All stations to central. So if we want to work out sine of theta, it's going to equal to negative sine of alpha, because only cos is positive. And sine of alpha is 6 over 10, or 3/5, but it's negative. Cos of theta is going to equal to cos of alpha, and it's positive in this quadrant. Cos is 8 over 10, which is positive 4 over 5. Tan of theta is going to equal to negative tan of alpha. Tan of alpha is 6 over 8, or 3/4, so it's going to equal to negative 3/4. Okay, let's move on. So now we know how to do that. Let's have a look and see if we can use Pythag to find an unknown side, and then we can find sine, cos, and tan for each of these. So I've only got 2 examples here. I'm going to go through the first one with you, then you can have a go with B yourselves. So we need to find this missing side. We know that this is a right angled triangle, so we can use Pythagoras' theorem to work out the length of the hypotenuse. So we've got root 5 squared, which is 5, plus 2 squared, which is 4, so that's 9. Square root of 9 is 3. Okay, so we want to find sine of theta, opposite over hypotenuse, 2 over 3. Cos of theta is equal to adjacent over hypotenuse, and tan of theta is equal to opposite over adjacent. Now, if you want to rationalize the denominator, you can just multiply it by root 5 over root 5, which is equal to 2 root 5 over 5. Okay, so that's only if you don't want to leave a third in the denominator. To be honest, I really don't mind if you just left it as this answer without rationalizing it, because to me, you know how to work out what tan theta is equal to. I'm not testing your ability to rationalize the denominator. And we can see here that in this quadrant, the first quadrant, all trig ratios, sine, cos, and tan, are positive. Okay, so we don't need to worry about any negatives. So if a question were to ask you, what's the coordinates of that point there? The coordinates of that point is cos theta, sine theta. All right. Pause the video, have a go with question B yourselves. Okay, so we've got the hypotenuse is root 13. So root 13 squared, maybe we can call this x if you want. X squared is equal to root 13 squared minus root 2 squared, or 13 minus 2. So x is equal to root 11. Okay. So remember, this angle here is theta. So this small one inside the triangle, we'll call that alpha. So sine theta is equal to minus sine of alpha, because remember only tan is negative in this quadrant. What is sine of alpha? Opposite over hypotenuse, but it's negative. Now, if you want to rationalize the denominator, you can. We can multiply it by root 13 on root 13, which is equal to negative root 143 on 13. But like I said before, I'm happy personally if you've left it like that. I'm not sure about your teacher, but this is me. Alright, if we want to find cos of theta, that's going to equal to negative cos of alpha. Cos of alpha is root 2 on root 13. And I'm just going to leave it like that. Tan of theta is going to equal to tan of alpha, which is positive, because tan is positive in the third quadrant. And tan of alpha is root 11 on root 2. Okay, I'm just going to leave that answer as is. Alright, let's have a look at the last part of this lesson. We're going to go through a variety of different problems. So let's have a look at the first one. It is known that sine theta is equal to 1 over 4. Find the possible values of cos theta. So it's important for us to remember all stations to central. So in which quadrants is sine theta positive? I know it's 1/4, but the important thing is that it's positive. Well, it's in the first and second quadrants. So what we can do is we can just draw a right angle triangle. We know that opposite over hypotenuse is 1 over 4. And we can do exactly the same thing on the other side. And remember, it's just a mirror image. Okay, reflection across this y-axis. Opposite is 1, hypotenuse is 4. Okay, because it's sine. Opposite over hypotenuse. And so now what we could do is we can use Pythagoras' theorem to work out the length of the unknown side. We have 4 squared minus 1 squared is 15. Square root of 15 is just root 15. So each of these lengths are root 15. So if we wanted to work out cos theta could be here, which is root 15 over 4, okay, adjacent over hypotenuse, or theta could be this angle. Okay, so cos theta would equal to negative cos of alpha. Okay, because only sine is positive in the second quadrant. And cos of alpha is root 15 over 4. So we can see cos theta is equal to positive or negative root 15 on 4. Alright, question B. It is known that tan theta is equal to positive 2 over 5. Find the possible values of sine theta. All stations to central. Tan is positive. That means it has to be in the first quadrant. Tan is opposite over adjacent. So we are going to do the same thing in the third quadrant where tan is positive. Okay, opposite over adjacent. Okay, so we are going to find the possible values of sine of theta. So if theta is here, we now need to use Pythagoras' theorem to work out the length of the hypotenuse. 5 squared plus 2 squared is 29, so this is root 29, which means this is also root 29. Okay, so sine of theta. I'm going to look at the first quadrant, this section, or that triangle. Sine theta is equal to opposite over hypotenuse. I'm going to leave it like that. If you want to rationalize it, you can. Now let's look at the third quadrant. If, however, theta was this angle, and therefore this is alpha, sine of theta will equal, in this quadrant, negative sine of alpha. Well, what is sine of alpha? Opposite over hypotenuse, except it's negative. So these are the two possible values for sine of theta. 2 over root 29 or negative 2 over root 29. Okay, I'm going to go through one more question with you and then you can have a go at question D. Let cos of theta equal to negative 3 over 5, where theta is in between 180 and 270 degrees. Okay, so we know that this is 90. Let's put in 0 as well. 180 and 270. So we know that the angle lies in between these two, so it's in the third quadrant. It's going to lie in this quadrant right here. Alright, and because it's all stations to central, only tan is positive here, and that is why cos is negative. Okay, so let's draw our triangle. We know it's adjacent over hypotenuse. Adjacent will be 3, hypotenuse will be 5. Therefore, we can use Pythagoras' theorem to work out that this is 4. Okay, 5 squared minus 3 squared is 16, root 16 is 4. Therefore, what is sine theta? Remember, this is theta, which means that this little bit here is alpha. So, sine of theta, in this case, is going to equal to negative sine of alpha. Negative because only tan is positive. What is sine of alpha? Opposite over hypotenuse, 4 over 5, but it's negative 4 over 5. What is tan of theta? Tan of theta is going to equal to positive tan of alpha. Again, because this is the quadrant where only tan is positive. What is tan of alpha? Tan of alpha is equal to opposite over adjacent, 4 over 3. Alright, let's find theta to the nearest minute. I'm going to use the trig ratio for tan because it gives us a positive answer. So I'm just going to use that one instead of cos or sine. So we know tan of theta is equal to 4 over 3. Actually, let's use alpha. Tan of alpha, because that's going to give us the reference angle. Tan of alpha is equal to 4 over 3. Therefore, alpha is equal to the inverse or arctan of 4 and 3. So let's put that in our calculators. Make sure your calculator is in degrees, not radians. And we'll put it as 4 over 3. So to the nearest minute, that's 53 degrees and 8 minutes. Okay, so that's how big this angle is. This one here. So if we want to work out what theta is, because we know to work out the reference angles for the second quadrant, we do 180 minus the angle. For this one we use, so let's say the reference angle alpha is equal to that. In the third quadrant, the reference angle is equal to theta minus 180. And in the fourth quadrant, the reference angle is equal to 360 minus theta. So because this is in the third quadrant, and we know that alpha is equal to theta minus 180, because alpha is 53 degrees and 8 minutes, theta has to equal to 53 degrees and 8 minutes plus the 180 degrees. So let's just add 180. And that gives us 233 degrees and 8 minutes. And that's theta to the nearest minute. Okay. Pause the video, have a go with question D yourselves, and when you're ready to check your answers, continue playing the video. Okay, so here it says let tan theta equal negative root 3, where theta is in between pi on 2 and pi. So we know this is 0 or 2 pi. This is pi on 2. This is pi. And this is 3 pi on 2. So it's between pi on 2 and pi, so it's going to lie in the second quadrant. And with all stations to central, we know that tan is negative in the second quadrant because only sine is positive. So that's good. Alright, so we can always write this as a fraction, negative root 3 on 1. So I'm just going to draw my right angle triangle. This is theta, this is alpha, and it's going to be root 3 on 1, opposite over adjacent. Okay, so let's find sine of theta. In order for us to do that, we still need to work out the length of the hypotenuse. So 1 squared plus root 3 squared is 4. Root 4 is 2. So sine of theta. In this quadrant, sine of theta is equal to sine of alpha. It's positive. What's sine of alpha? It is root 3 on 2. What's cos of theta? Cos of theta is going to be negative cos of alpha. Again, because only sine is positive. Therefore, we've got negative cos of alpha is half. Find theta in radians. So I'm going to pick sine because it's positive. If sine of alpha is equal to root 3 on 2, alpha has to equal to the inverse or the arc sine of root 3 on 2. I'm going to work that out in our calculators. Again, just keep it in degrees mode and we can convert it to radians later. So shift sine root 3 on 2 is 60 degrees. However, we want to work out theta, not alpha. And because this one, alpha is equal to 180 minus theta, 60 is equal to 180 minus theta. Theta is therefore equal to 120 degrees. However, the question asks us to work out the answer in radians. So we know that pi radians is equal to 180 degrees. So if we want to work out how many radians there are in 120 degrees, we just take 120 divided by 180. Right, as a fraction, 2 over 3. So it's 2 pi over 3 radians. So we can say, therefore, theta is equal to 2 pi over 3 radians. Alright, last one. Find tan theta if cos theta is equal to negative root 2 on 2 and theta is a reflex angle. So the first thing I would do is I would draw a circle. As best as I can, it's good enough. Okay, so we know that cos theta is negative, all stations to central. So it has to be either in the second or third quadrant. But we know that the angle is a reflex angle, which is more than 180, so it has to be in the third quadrant only. So I'm going to draw my right angle triangle. Cos will be adjacent over hypotenuse. Adjacent over hypotenuse. And now I can use Pythagoras' theorem to work out that last side. Pause the video, have a go with this one yourselves. Alright, so I'm going to use Pythagoras. 4 minus 2 is 2, so this is also root 2. So if this is theta, and this is alpha, I know that tan of theta is equal to tan of alpha, because in this quadrant, tan is positive. Tan of alpha is opposite over adjacent, which is just 1. And that's it for this video.